Hello and welcome. This is K.L. Johnson speaking to you from humble Wichita, Kansas. This is called Maker's Space. And this is actually a project that a group of my students came up with one year. First graders, with the help and collaboration of some of the middle school students. And it is called box bowling. So basically, all kids, you give them the toy and what are they going to play with? You guessed it, the cardboard box. And so that's what this basically is. We have all of these discarded cardboard boxes, and the experiment is not going to begin with the mother of all, which the whole idea of this is to see what will cause the what do we call them, pins? No, I think we're going to stick with the original term, structure. We want to knock this structure down. And are we going to be able to accomplish that with this lightweight? We might be able to, because look, it's got a lot of surface area. And we learn a lot of words and terminology that is related to physics. A ping pong ball, you might not think could knock it over, but with the correct velocity, or the rate at which we catapult it or whatnot, which reminds me, I forgot my hold on here. We are going to use, like, this is a puffy, you think this, well, it's really cool how it lights up and everything, but do you think that's going to knock down an entire cardboard structure? But I forgot something, because we want our throws to all be uniform. Excuse me. So, in order to make the throws uniform, to make this experiment work, we can either use this handy dandy catapult, I don't know if you can see that from here, where we launch our spherical devices, or we can use this, which if you have a uniform rule for how you swing it, you can pretty much use your arm as the pivot point, or the lever where the fulcrum is, and you can get uniform results. So, of course, obviously, we're not going to be able to throw this, but I just think this is interesting because students thought in first grade that this was more likely to knock over the boxes than this, and this is yet more dense, but they didn't think about that. They saw that this was bigger. But anyway, so I'll just give you a little example. So I might start, we always start with the one that we think is most unlikely to knock it over. So I might take my little thing, create my little fulcrum with my arm so that I get relatively similar catapult or, launch of the ball. Okay, we have a certain distance. It would be behind this camera, and I'm going to shoot. And that didn't work, so let's try another one. I'm going to shoot using my arm as a lever. And it just seems to bounce off. Most of the time, believe it or not, it actually goes through those little slits. And so I might think these cloth ones might be my next call. Pretty cool, huh? So I might try to knock it down using these. And because they're smaller, they may not necessarily even hit, but if you can, well, that didn't work. Okay, so then I might move up to something like this little football. It's very, I wish I could have you, if I could reach in there and let you just feel how lightweight this is. But anyway, so, box bowling, we're trying, the object is actually to demolish our structure. And believe me, the kids put this together, so they don't really they're attached to it. But anyway, that's what the whole point of this game is, to do what kids love to do. Build something up and then knock it down. So, the next ball I might pick, and I let the students decide this. And we may have to redo our experiment if we think there may be, now I can't think of my terminology. But anyway, if we believe that it could be skewed because of a faulty decision of a person, like, let's just say someone chooses this ball over this ball, and you can't fill it, but this ball is heavier than this ball. And let's just pretend they're about the same size, or maybe we've got, like, this ball. This one is actually denser. It's heavier. It's more likely to have an impact. When we get to the point where we can no longer use this, we still want to use our arm as the lever and our elbow. And our elbow, mostly we want to try to use the joint in our shoulder to be the fulcrum, because we want to keep things the same. So let's say I move on to this one. Okay, it's pretty lightweight. I'm going to use my arm as a lever. Oh, it's just, well, this box bowling thing isn't going so hot, is it? We may need to up the ante a little bit, guys. So why don't we try this one? Since it's the biggest, therefore it must what? It must be the winning ball. So this one I'm going to need to use my arm and roll. Surprise, surprise. A lot of good that did. Well, world. I guess we're going to have to find something else. So let's try to move this, to get this moving quite along. Let's try the densest one of all. The one that wasn't likely chosen as the one, and we wouldn't have all this stuff in the way. I have these long garden things that the balls are kept in. So then we stay the same distance back, and we are going to use our arm as our lever, and we are going to, oh! A teacher's job is, well, let's say, it's a little messy. Hey, all you first graders, can you do me a favor and clean up this mess? Spit spot! But this is box bowling. And I know it seems like, but you can incorporate basically into anything fun. And my students came up with this. They were using wooden blocks, and I felt like that wouldn't be such a good idea. Someone might get hurt. But they came up with this, and all I did is tweak it just a little bit to where we could make it a little more scientific. And this is creating a maker space. Like K.L. Johnson, speaking to you from humble Wichita, Kansas. Thank you.